In our next example, we're going to factor this as well. Now this is a special type of quadratic, and it is called a difference of perfect squares. And that's because our expression here has a negative sign in the middle. That's our difference. So this negative sign is our difference. And then it also has two perfect squares. The first one is x times x, and the second one is 3 times 3, which equals 9. So when we break this down, it becomes the square root of the first term goes at the front of the parentheses. The square root of the last term goes at the back of the parentheses, and there are always opposite signs. So if we check this, we FOIL. So our first, we get x times x, which is x squared. Outer is negative 3x. Inner is positive 3x. And last is negative 6. These cancel because one's positive and one's negative. And we end up with x squared minus 9. Since we ended with the same expression that we started with, then our factoring is correct. So the key with the difference of perfect squares is that the signs have to be opposite. One has to be positive and one has to be negative. And that is so our middle two terms here will cancel each other out. If it's helpful to have a formula to remember, here is a formula for a difference of perfect squares. So when we have something squared minus another thing squared, they break down into two parentheses. The first term goes at the front and the second term goes at the back with an addition and a subtraction sign. For example, 1C, we also have two different terms here, and it is a quadratic, and we're asked to factor. The first thing we're going to do before we factor is something called common factor. And it's actually the factoring that you're probably most familiar with, but it's also the factoring that most students forget to do. So you look for what is common in both terms, and we factor that out. So what's common in both terms is 4. So when I factor a 4 out, I get left with x squared minus 16. And now what I've actually done here is I recognize that this is now a difference of perfect squares. So I'm going to leave that 4 in the front, and then I'm going to factor the next part. So x times x gives us x squared, so that's going to go at the front of each parentheses. I have a negative there, so I need a positive and a negative sign. It doesn't matter which binomial holds which sign. And then 16 is the product of 4 times 4. And that is our final answer. So for this one, we actually had to common factor first.